Alrighty, so it's been about a week, and my parts came in, so I'm really excited. So over here, these are the replacement RAM chips for the ColecoVision. We've got our sockets, and we've got our actual chips. So I'm going to be doing that a little later. It's kind of late tonight, I don't want to start on something super risky. But my switch also came in. So I got this little flip switch, which feels really solid. And what I'm going to do is I'm going to use this Molex connectors that I have as scraps, and I'm going to connect one end to the motherboard and the other end to my switch. And the intent is the switch is going to be mounted into the case, and then these Molex connectors are going to allow me to connect and disconnect the switch, so that way I can separate the top and bottom halves of the ColecoVision, even though the switch is going to now be mounted to the case, which it previously wasn't. Originally I was thinking I was going to have to glue the switch, but let's see if we can get a really good shot. Use the laptop as contrast. So you can see there's these clips on the side of the switch. They press in. So I can do this while I'm holding the camera. Yeah, they kind of give and press in, and there's a pair of them on each side. The idea is that this slips in through the top of the case, like so. And then the clips, there's a little space there. The case is going to sit between this outer part and this clip and hold it in place without needing glue, which is fucking sweet. That means the installation of the switch, keeping it solid, it's going to be a lot easier. So I'm going to solder this end to the board. Then I'm going to insert the switch into the case and install the other end to the switch. Should make this whole thing super easy. Actually, let me check and see, can I actually fit this through here? I can. So I don't even need to connect it yet. So I can just solder this straight to this, and then later on feed it through the hole and set the switch in place. Then I'll have my switch. And then what should happen is once it's installed, we should be able to boot up the ColecoVision and get exactly the same results we've been getting. But I know the switch works, and it's a lot better than the old switch. The advantages here are, one, it's no longer relying on being mounted to the board for stability, it's now relying on the case. Great. Secondly, it feels a lot more solid and it's a lot newer. This is a really nice switch, I'm happy about it. Yeah, so that's the game plan. And next step then, I'm going to go ahead and do the solder work and get this all set up, and then we're going to test and verify the switch works. Now you also notice there's 4 wires, but there's 6 holes and 6 pins. So as we saw in our previous video, the way the slider switch worked is you had essentially metal contacts that were bridging pairs of pins on either side of the switch, sliding back and forth. Now, in the off position, 2 pairs of the pins actually aren't being used. So, all we really need to do is connect the live power, which as far as I've read are these middle 2 pins, and wire up what the lines that should be active when the system is on, which should be these top 2. So if we don't wire these bottom 2, then the circuit is still broken when the switch is flipped off. Therefore, we save ourselves 2 wires, and I can use these handy dandy Molex connectors that I have lying around and get my solder-free disconnect switch apparatus. So yeah, next up, let's do some soldering. Alright, so we've just wired up our switch. I got my game in. So the switch is in, power is connected, and we have video. So let's see what happens when I flip the switch. Hopefully no sparks. There we go. So the switch works beautifully. And we're also back to where we started, which is what I expected. So, flip switch. That is amazing. Next up, replacing the RAM. Okay, so we've tested and verified that our new switch works, and that's wonderful. So real quick, I wanted to talk about what preparation I did to make sure that the switch worked as expected. Since it was running power to the board, I was really nervous about breaking something. So, after I connected the switch, Molex connector to the actual switch, before putting any power into the board, what I did was I connected the switch I would flip it on, and I checked to see that the rails for I think this is the 12 volt and this is the 5 volt. I might have them backwards. But I made sure that that if I use my multimeter over here, setting it to detect resistance, which, oh well, it's out of range. Like right now, if I were to take my 2 probes for my multimeter, turn this one-handed, have them touch, they detect 0 resistance. There's a little fluctuation because my hands aren't steady, but there should be about 0 resistance, which would make sense because it's a completed circuit. So you can use that same principle on these pins. So I'd do that, flip the switch on, and I'd make sure these pins had 0 resistance between each other, and same thing for this pair. And I'd also check to make sure that there was always infinite resistance between any combination of these 2 pins and these 2 pins, to make sure I didn't short anything. And also verify when the switch is off that there's infinite resistance between each of these individual pairs on either side of the voltage rails. That's a nice way of making sure that you didn't short anything and aren't going to smoke up your board when you run power through it. So I've done that. Now I'm going to be moving on to probably the scariest part of this project, which is replacing these RAM chips. Now it's not just a matter of replacing these chips, because there's also different voltage requirements for the new chips. It's supposed to make it more heat efficient because it only runs a single voltage. So I've been reading through the directions multiple times to make sure I understand what I'm doing. But essentially, we're removing these 2 guys right here, and then we're taking one of the leads off of here, and I believe we're connecting it to one of the capacitors up here. The directions aren't super clear about that second step, so I'm going to see if I can find some better pictures and documentation about it. But once that line's connected, we're next going to go ahead and desolder each of these 8 integrated circuits that we see up here. That's probably going to be the most challenging part because there's kind of small leads, and I am not super great at soldering. I'm okay, passable for what projects I've done so far, but this is going to definitely be the most difficult soldering job I've had to do. Once these chips are removed, let's see if I can find these guys real quick. I don't want to just start shoving the camera around. Oh, wait, they're right next to the board. I'm done. So once those are removed, then I'm going to have to install these sockets, solder the pins like the current chips are to the board, verify that all those pins are getting proper voltage, and then install the RAM and test to see if the ColecoVision does what it should. So as I'm removing stuff, I will step by step along the way and try to provide a little insight into what I'm doing. But overall, this is the game plan. I'll be using my almighty soldering iron to heat up solder when necessary. I've also got a desoldering iron that I'll use for removing these 2 components. I will try using it on these ICs. I'm hoping the leads aren't too small, and that should be pretty easy. We'll find out. And if I hit difficulty, I'm going to opt for safety over anything else, and I will stop before damaging any components, hopefully. So let's see how this goes. It's like brain surgery. What could possibly go wrong? Alright, so with a lot of patience and not really a whole lot of elbow grease, I'm going to get some of that crap off the end of that. We went ahead and removed the components that were sitting here and here, which are these 2, what are they called? Sorry, I'm going to look back at the documentation and see what these components are actually called. Well, there's called L2 and L3. I'm going to be lame and not really know exactly what these components are. Sadly, I am not an electrical engineer, so I am limited. But these 2 guys needed to be removed from here and here. And looking at the next page, as you can see, we have L2 and L3. The rightmost pin on L3, or that pad rather, needs to be connected to, you see we have these ceramic, shit, I'm an idiot. Why don't I remember what these are? Ceramic capacitors. Alright, So these 3 ceramic capacitors. This middle one, obviously you can see there's going to be 2 pins running the vertical. The middle ceramic capacitor, its pin closest to the bottom, needs to be bridged with the rightmost pin on L3. So what we're going to do is we're going to take a small piece of wire. On the opposite side of the board, we're going to do that solder work. And the intent is to connect the plus 5 volt line to L3 so that it could provide the necessary power to our RAM chips. So we're going to go ahead and do that next. And also, this is the almighty desoldering iron that I use to remove the components. Essentially, you can see it's got a slightly fatter tip and it's got a hole in it. So the idea is you insert the tip so that the leg of the component goes inside the hole, move around the head slightly so that the hot tip touches the solder that's at the base of the pin and melts the solder. And I need depth perceptor for this. So there's this balloon that you depress, and then you melt the solder, then you let go, and it will suck up the solder. And that's how I go about removing components. And you can see from this tray here, this is where all of the solder has gone from the things I've desoldered over time. I should probably clean that at some point, and there's probably a better way to do it, but that tray was convenient, so that's what I use. And so I don't burn the shit out of my table, I took this old little, I think it was an adapter for some PC component. I use that as kind of my stand for my desoldering iron, since I don't have a great stand like I do for my soldering iron. So yeah, next step though, we're going to bridge those pins. I'll show you that once we're done. Okay, so our mission was to connect this lead down here to this middle, oh, no wonder I can't point, it's the wrong thing. So our goal is connect this far right lead to this middle ceramic capacitor. Now the directions called for using some sort of solid wire like the leg on a resistor. However, I don't have a spare resistor because I'm a terrible electrical engineer. But what I do have are these components that I just recently removed off the board. So I took one of them and I smashed it apart. There's the poor little remnants of it. I took one of the legs and we get a good shot of that. Yeah, you can see kind of right to the right of the light halo, that goofy ass. Let's see. I can't do 2 things at once. Give me a moment. I'm going to set this down. Oh my god, you're seeing my face. Maybe. Okay. So, right here, because the camera focus sucks, I essentially just took that wire and laid it across the pin and the pad that I needed to solder it to. Glob and solder on either end, and just kind of melted and flowed everything until it all melted together nicely. And now that connection is bridged. Great. So now the next step, you can see the legs on the bottom here. These are the memory chips. So I'm going to have to start removing them. This is where things get into really unknown territory. So we're not just playing with larger components anymore, we're playing with integrated circuits. The pins are smaller, the leads are smaller, and there's less solder to work with. So let's see how I do. Okay, so I just got my first RAM chip off. Sweet. And it wasn't too bad. I did have some complication. So let me see if I can, yeah. So here's the RAM chip I just took off. And here's where the complication came in. So as you can see, a bunch of the legs are missing. So I got the solder off. The desoldering iron actually did great getting the solder off. The problem was I had 1 or 2 problematic pins that just were being really stubborn. So what I opted to do is, since there's a little bit of open space on this side, I took my wire cutters here, and I started cutting the legs off the RAM chip. And once I got through the problematic pin, it started just lifting out, and then I just had to work the other pins out. As you can see, it came out pretty clean. Reading online, there are some concerns about lifting the traces off the board, so I'm trying to be very careful to not force anything, and to make sure I get all the solder off before I attempt to remove the chip. Otherwise, it seems like it's very doable with the equipment I have. I just have to be careful and be patient. And again, now that I've got the first one off, I've got this nice open area to start cutting pins if I need to start making my way across. This is really the problem with doing the first one was, there's chip on one side, this heat sink on the other, these ceramic components on either end, so it's really kind of just sitting in there, and it's hard to get at with such a large cutting apparatus. This is for an electronics kit, but they're really big. They're not really made for cutting something this small. So right now that's my strategy, essentially remove all the solder, just try to work it out. If it is being stubborn, just start cutting legs from the top, and as soon as they come out, then usually the legs will come out fine from the circuit board itself. If not, then I just use my combination of my desoldering iron and my soldering iron to loosen any rogue solder that's probably keeping it in place, and being very careful not to destroy the conductive pads on the circuit board. So I got one done. I'm trying to knock the rest of these out. So I've got some confidence right now. Let's see where this goes. Alright, so I've just gotten all the RAM chips off, and it was a lot of work like what I expected. As I went through, I developed a couple techniques to try to make it easier. Now mind you, I'm going to describe this whole thing as probably like electrical engineering butchery, or just electrical butchering, hardly engineering, because I'm working with tools to remove these chips, but I'm sure I don't have all of the proper tools. What I ended up using is I had a desoldering iron, which, as we'd seen before, it has a hollow tip, so you can put the tip down and have the leg of the component go inside the head of the iron and heat all the solder around it. Let's see where I'm putting it so I don't burn something. Soldering iron with my nice digital soldering station. This is actually still hot. It has a nice fine solid tip. Well, rubbing alcohol, I was just using it to clean some stuff, ignore that. And canned air. And last but not least, needle nose pliers. So normally what you're supposed to do is you've got some IC. Let's see, do I have any that don't look like crap? No, I don't. So, okay. We'll look at, this is the new ones I'm going to be installing. You see how, it's got these legs running along, and they're wide on top and narrow on the bottom. And it's got 8 legs on each side of the chip. And those go in the holes. They sit through, and then there's solder on the bottom side that solidifies the connection and keeps them in place. Normally you're going to have some sort of an iron component that allows you to heat all the pins at once and lift the chips out. Well, since I don't have that, I resorted to butchery. Essentially what I did is I used my desoldering iron, and I went over each pin individually, from the underside, went through each pin, and just removed as much solder as I could, and oftentimes not much solder would get removed, or the solder would flow into the hole as opposed to on the surface where the iron can get to it. Now when I first started, let's see if I can find a good example. It might be kind of hard to see from the camera. Like some of these holes over here are a little more messed up than others, where I had tried repeated applications of the desoldering iron to pull that solder out, but it just wasn't coming out, and the pin would remelt with the solder to the side of the hole, so it was still stuck, and all sorts of nonsense. So I'd wrestle with that for a long time. But as I'd said when I started this, I was going to be careful, and if I ever started to try to rush things or if things seemed difficult, I would walk away, give myself a break, and come back to it in a little bit. And it took me about, overall it was about 3 hours of work, but I did it over the course of 2 days, just because I'd come back, do a chip or pull some pins out, and then be like, okay, it's getting a little tough, let's walk away. So what did I end up doing? By the time I got to the last 2 or 3 chips, I had a strategy down that the idea was to minimize the impact of potentially damaging the board and still make it possible for me to install the new sockets. So what I did is I went out to local electronics shop, which has a lot of really good stuff, and got these nice side cutters. So I got these guys. And what I would do is I would take the desoldering iron, I'd remove as much solder as possible. And also the way those chips were inserted into the hole is that they were inserted and then bent and then soldered. So I'd have to straighten the pin, which I did with the desoldering iron since it's hollow. Well, let's see. This is going to be our prop pin. So I would insert the soldering iron, that would heat all the solder around the pin, and I'd apply a little force to bend the pin back straight. And I'd suck up as much solder as I could. A lot of it would flow into the hole and it'd be kind of a pain in the butt. So once that was done, I did it for all 8 pins. Then I would turn the board on its side, and I've got these clamps set up. So essentially what I would do is I would prop the board between my 2 clamps because I don't have a good set of helping hands. So I'd have it sitting sideways. And I'd rest my chin on the top. Again, this is butchery. So the board would be sitting sideways, my chin would be supporting it, so my hands would be free. On one end, I would have my pliers. Or, I'm sorry, I skipped a couple steps. Let's rewind. Terrible. So, okay, we've straightened the pins, we've gotten most of the solder out. So now we've got the IC sitting in on the board with straight pins, but it's more or less still attached. I would take my side cutters, and I would actually cut the pins off. So you can see this is an example of one that I had removed. Essentially, if it's sitting on the board, I take my cutters and just snip along carefully, getting as close to the actual chip as possible to leave me as much pin to work with my pliers. So do that, and I'd remove the chip. So now we have a bunch of pins sticking out of the board with solder on it. Then we do the sideways board thing supported by these clamps, as I described. And I have 2 free hands. My chin is now supporting the board, holding it on the side. With my right hand, I would use my needle nose pliers, and I would grip the pin. And as we can see from these pins laying down here, you can see an example of one. Again, it's wide on one end and narrow on the other. The wide end would be sticking out of this board, so it gives me a nice tab for the pliers to grab. On the other end, I would take my soldering iron with its narrow tip, and I would insert it as close to or in the hole where the pin was sticking out of, which would cause the solder to liquefy because of the heat, which would then make the pin loose. And then the constant pressure of slight pulling from the tweezers or pliers would pull the pin out, and then I'd set it on the side, hence why we have all these pins here. And I did it for all 8 pins. Now what we're left with is a bunch of holes with no pins, but they have solder in them because the solder flowed into the hole. So at that point, flip my board upside down, and we'd have our solder holes or whatever, and they'd be filled. I would again take my soldering iron, stick it in the hole to liquefy the solder. Then with one hand, while the soldering iron is being held there, I'd take the other and shoot a little canned air, which would blow the liquid solder out of the hole. Most of it would just end up on the table, which is great because I've removed it and it makes my job easier. I don't think you're going to be able to see it with this camera because cell phone cameras are fucking terrible. But some of the solder would also re-solidify on the top board side of the hole, but it's open and it leaves me a hole to put the new socket in, which is fine. So doing that strategy, essentially straightening the pins, snipping the legs off the chip, using pliers and soldering iron to remove the pins, and then blowing free the holes for the board, I removed all my chips. Doing that, I was able to knock out 3 of the chips within about, 40 minutes. It's pretty easy. So anyway, those are now removed. The next step now is I'm going to double check my directions, but then I'm going to take my sockets and install them in these holes and solder them. And I'm hoping it's going to be a lot easier. Because these aren't that big of, or these aren't that small of pins. They're kind of small, but not really. I can work with it. And I won't have to diddle around with trying to figure out how to get these chips out. Since I'm soldering the sockets and not the chips, I don't have much risk of damaging the chips with the heat from the soldering iron. So anyway, that's my next step. See how I do. Alright, so I just installed my first socket. Overall, it's pretty easy going. Essentially, since I had originally blown all the solder out from the bottom to the top of the board, there's a bunch of crud solder sitting above these holes that makes it hard to get the pins in. So before I started, I went ahead and blew the solder back down the other way. And let's see, where do I have that sitting? Yeah, there it is. And essentially what I would do is I would set, using the top of the RF shielding, I would set the board on top of the RF shielding so that the socket, or the cartridge slot was, or that hole was sitting underneath the RAM socket I'm intending to solder. So I'd do that, then using my soldering iron, stick it in the hole, melt the solder, shoot it with the duster, and that would clear the hole enough to get the pins in. And then I'd push the socket in. Some of these pins, because you can see, essentially this is just a plastic assembly with a bunch of individual metal pieces set in there. Some of them would not go through all the way and kind of push up. because there's still a bunch of solder just kind of stuck around in the hole. So I'd get what I could in. Then, taking my junk precision screwdriver, I would insert it into one of these pin slots to apply pressure, flip the board over, and I'd use my soldering iron again to soften the solder in the hole that's blocking the pin. And then as I soften it, the pin slides in like it should, everything works out, and in fact it's really nice and sturdy in there, so when I apply the fresh solder to complete the connection, the slot isn't going to move around. As you can see on the other side. This is my new solder job. Kind of hard to see with the crap camera, but yeah, other than that, I just then hit it with a little bit of solder on each pin, and everything goes in. So I'm going to go ahead and do the rest of these now. This is this is a lot easier than removing the old ones, and the hope is once all the sockets are in, if I ever have to do something like this again with these specific chips, I just remove the chip. I don't have to screw around with all this other business. Alright, so I just finished up installing the sockets, and like I was saying before, it was pretty easy. I'm actually very happy with that. The pads on the opposite side of the board worked well for me to melt the solder and get all the pins together, so that gives me some confidence that I didn't completely screw up this board. I didn't see any shorts or anything. Just as a testament to how sloppy my original removal of the ICs were, though, I'd started going this direction and then moved up here and went the opposite direction. So these are all really easy to get in. But for a couple of these, I actually found little scraps of legs of the previous ICs that I just somehow missed as I was pushing these pins through because they were stuck or jammed. So yeah, you learn when you do things. That's probably one of the more valuable parts of repairing these sorts of consoles. On top of getting a working system, hopefully, you get better at this and you don't screw up in the same way. So next thing, I'm going to put the RAM chips in, and then we're going to fire this up and see if I've just solved this. Alright, so I'm going to do a smoke test, so to speak. Fire this up without a cartridge and just see if anything starts smoking or blowing up, because we did do a lot of modifications to the board. As you can see, the RAM chips are now installed. One interesting slight complication is that the chip pins were kind of wide, so it's hard to get them in the socket. So I took my fingers and kind of just gently bent them just a slight bit to make it easier to get into the slot, or the sockets. So those are in, power's on, TV's on. God, I hope nothing blows up. Well, that's not promising. Nothing blew up. But I wouldn't expect that screen. Well, why not try? What's the worst that could happen? He says as he struggles to get a cartridge in the slot without being able to see the damn thing. It's probably not going to work. Yeah. Okay, so something is wrong. Mostly black screen. Check, make sure power's on all the way. Yeah. So, I'm going to do a little reading and see what I can figure out. Alright, bummer. Well, we learned something, but we don't have a magical working ColecoVision. Alright, I'll see what I can dig up. So I went ahead and started checking a bunch of traces, and I found that there was a broken trace that connected two of the RAM pins underneath the board. So I went ahead and jumped that using a wire. Now, if we turn on the console, still not fixed, but it is better. We're almost back to where we were when we started this stupid thing. So I'm just going to keep checking traces and see if there's anything else broken, because if so, that's a start. So stay tuned. So as I mentioned before, I had found a broken trace, which is this guy right here, connecting these two pins. That was broken, so I went ahead and just took a wire and bridged that. I also went ahead and pulled up some schematics on the memory chips themselves, and I noticed that one of the address lines was not connected to one of the RAM chips, so I went ahead and bridged that as well. So now if we go ahead and take those two fixes. I'm going to try to do this one-handed. Forgive me if I give a poor shot while I'm trying to do this. My little test rig has been essentially to use the bottom half of the case. Just so I got something to set it in. Okay. And power cord. I haven't impressed myself that I've been able to get this assembled so far without using two hands. The Molex connector may be my undoing though. You have to give me 1 second, I need two hands. Okay. Sorry about that. So connected my switch and my RF. Connected it there. Okay. We go over to the television. Turn on. I got this set for my workstation over here, so it's not quite as close as it was when we were seeing previous tests. Come on, television. There you go. Alright, so those two fixes. It's still borked, but it's less borked. More of the letters are correct, and we don't have the crazy blue background anymore, so we're getting closer. I'm suspecting I'm going to find more broken leads or more broken traces I have to fix. But yeah, so this ColecoVision was in worse shape than I thought. I'm even starting to wonder if replacing the RAM is going to have nothing to do with the fix, and it's really going to be me fixing the traces. So I'm going to keep double checking the RAM section and see what else I can find. Alright, so I went ahead and was double checking all the pins on my RAM, and I found that firstly there were a couple pins on the chips that had not made solid contact with the socket because I'd bent them in a little bit too far. So, word of warning, if you get socketed chips, don't bend the pins to make it easier to get into sockets. Just screw around with it till you actually get it in. Essentially, I was checking pins and I'd see where pins that should be connected weren't. And then to verify that it was the chip, not the socket, I would flip it over and check the soldered leads for the sockets and see if they're actually connected. So even with that, I did find, make sure I grab this carefully, one more broken lead. So you can see now I have 3 different wires fixing broken leads. And my phone's ringing. 1 second. Hey Chris, give me 1 second. So I've gone ahead then, and with those wires in place, let's go ahead and plug it in. There we go. Plug in our RF. There we go. And with our television on, go ahead, flip our switch. And there we have a repaired ColecoVision, ladies and gentlemen. So with a little bit of hard work and a little bit of luck and a lot of research, you too can make broken systems work. So as we see, the main issue for this thing the whole time might have just been the broken pathways on the RAM. We'll never know because I did a whole bunch of other repairs anyway. But overall, I'm happy with this. Next steps now, go to Home Depot, get replacement screws for the rusted out screws, and then reassemble and enjoy my ColecoVision.